So I'm going to model a mechanism for drawing a periform curve. Here's the mechanism on that page there. This is a transformation-based mechanism. Transformation mechanism takes a given coordinate and maps onto different coordinates. So it's a 2-degree of freedom mechanism. We'll see how that works in GXWeb. So here's my mechanism. It's the transformation part of it anyway. We're going to have an auxiliary vertical line. Make it vertical and specify its location using the parallel distance constraint. So make that distance A. We're now going to have a line segment joining the origin to that vertical line. The sliders are used so that the length of this segment is not given. And we're now going to come interior to some point. We're going to come perpendicular. We have our mechanism such that BC is going to be perpendicular to the axis, to the y-axis, and the perpendicular angle between BC and CD. So now C is the input to our mechanism. Now let's just call that XY. And D is the output. So we'll see how D changes things. So coordinates of so we've transformed XY to X times Y over A. And that's going to, what we're going to do is drive C around some path, and then we'll watch our output where the D will be the point that traces the new curve. So let's get rid of this XY. The first thing we'd like to do is just use a circle as the location, as the locus of C. So we could do that by joining it to some fixed point. So we'll make that fixed by constraining its distance from the origin there, and we'll give this a length R. And we'll also drive it by an angle theta. So given that, if we were to trace C, of course, it would do a circle. Let's see it. Now there's our circle. I'd like to change its color so we don't confuse it with the other curve that we want. And D is the one that's going to draw the output curve. And so there is our output curve, known as periform. What's this equation? Go, just for comparison, the equation of the original circle. So that. Now, left the reader transform this into this using this transform that I will animate with theta So a particular form of this curve occurs when, of course, b equals 0. Let's just take a look at that one before we finish. Probably better than just reducing b to 0 would be to recreate the curve. Let me do that really quickly. Instead of having this line here, we're going to take this out of the picture, and instead we're going to create this line here. Make that R. And give a theta in here. So here we're seeing the curve that C follows. This is a clean circle there, centered at the origin. And then let's have the curve that D follows. Okay, that's a symmetric curve, where the previous one was not. Let's take a look at this equation. That's a cleaner equation to the final little piece of simplification is if instead of A, we put R here. So in other words, we put this this line so that it touches the circle. This is changed the shape of our curve, but it has an even simpler equation because we've lost one of the one of the parameters. A squared has become an R squared there. Okay, so this is the periform curve.